This is our final exam study guide. This is part 3. We're picking up at number 24. Number 24 says write the linear inequality shown in the graph. I had to put it on this because on the picture I pulled up came out all jumbled up, but it looks the same. You should still be able to get the same information from it. Write it as if it's an equation first. We know it's an inequality, but write it as if it is y equals mx plus b. The first thing we can see is what our b value is. Remember, b is your y-intercept. This is crossing through at 4. So on your y-intercept, your b value is 4. That's the first thing we can see. The other thing we can see is the slope when we count. The trick to finding the slope, though, is you have to find a point that it goes through where it's not in the middle of any lines. You want to make sure it goes through 2 intersections, like right here. So from the point that we had 4, we have to check the slope. See how many times it goes up or down. We know it's going to go down according from the red going to the green. So here we're going to go down 1, 2, 3. Down means -3. Then how many times you go right or left? We know it's going to go to the right 1 time. So -3, +1. Your m value is negative. We'll just leave it as -3. You don't have to show it as over 1. So y equals mx plus b. You want to write it as y equals mx plus b. In place of m, you plug in -3. So -3x plus b. In place of b, you plug in 4, +4. So your equation, if you were just writing an equation, would be y equals -3x plus 4. But this is not just an equation, it is an inequality. The next thing we have to do is we know it's shaded on the 0, 0 side. Remember, that's the point we use, the origin, 0, 0. So we know that everything on that side is true, which means that when we plug in 0, 0, it's going to be a true statement. So in place of y, we'll plug in 0. We'll leave the equals part blank for a second because we're not making it an equals equation anymore. We're making it an inequality. So 0 is something, and that something we'll fill in a minute, -3 times in place of x, 0, because it's 0, 0, plus 4. So 0, again, is something. Anything times 0 is 0 plus 4. 0 is something 4. We want to make a true statement because 0, 0 is on the true side, a true statement. We know that 0 is less than 4. So go back to your original equation, y equals mx plus b, and it's y equals -3x plus 4, mx plus b. Take your value, or take your inequality sign less than, and plug it in place of the equals. The last thing you have to do for this is you have to check, is it a solid line, or remember, solid line looks like this, or is it a dashed line or a broken line? If it were a broken line, we would be finished because it says less than. But it's a solid line, you can clearly see, so we have to make it say or equal to. Y is less than or equal to -3x plus 4. This is a tough problem. It's one we hadn't seen in a couple of months. Number 25, here we go. We got 4. So we have, for number 25, it says -8.6 to the 0 power. Anything to the 0 power is 1. You don't have to do any figuring for that. Remember, anything to the 0 power is 1. Number 26 says 4 to the -2 power. Now we have a negative exponent, 2. Remember, anything negative, it doesn't tell you that it's a negative number. It just tells you it's a reciprocal, or we use the term that it rides the elevator. So 4 to the -2 power, this is being raised to the -2 power. It's already at the top. It has to go to the bottom. So 1 is left at the top. The reason 1's left at the top is because if we had 0 at the top, then it would say 0 divided by something, which would come back out to 0, which is not what we're looking for. 1 over 4 to the -2 becomes 4 to the +2. That's the change you make. It goes down and it becomes positive. That means 1 over 4 times 4, which is 1 over 16. That's the answer to 26. If you're looking at number 27, 12 over, then it says c to the -8d squared. C is the thing that's being raised to the negative exponent. So it is the only thing that rides the elevator. It's at the bottom of the fraction. It's got to go up. You always want to put 12 first because it's the coefficient. I always put the number first if you. Okay, so it's the only thing that rides the elevator. You leave 12 first since it's the coefficient, and then C comes to the top of the fraction, and -8 becomes +8. So you have 12C to the +8 over D didn't move because it's a positive number already, D squared. We don't know what C or D's value is. This is all we can do with this problem. 12C to the 8th over D squared. Number 28, notice 12 times 12 times 12. All of your bases are the same. Anytime you are multiplying the same bases, you add the exponents. So it's 12 to the -3 plus 10 plus 0. -3 plus 10 is 12 plus 0 is 12 to the 7th power. And I'm pretty sure it'll be in this form right here. If it's not, just multiply 12 times itself 7 times. Or in most of y'all calculators, you can punch in 12, and then there's a button that looks like this. It's called a caret button, 7, and it'll give you the value of 12 times itself 7 times. Number 29, the difference between 28 and 29 is you are multiplying the same basis, so you added the exponents. For 29, it's raising an exponent to an exponent. So now it's 12 to the -2 times 6. You multiply them in this case. That becomes 12, I'm sorry, I keep saying 12, t to the -12. And remember, just like on number 26 and 27, a negative exponent has to ride the elevator. Everything's over 1. So this t has to go from the top to the bottom. So 1 stays at the top. T goes to the bottom. -12 becomes +12. 1 over t to the 12th. That's all you can do for 29. Number 30, we have this great long problem. You do 30 just like the end of the beginning of 30, just like we did 29. Make sure squared goes to everything though. Squared goes to -5, so -5 squared. Squared goes to g to the 5th, so it's g to the 5th times 2 since you're raising an exponent to an exponent. And squared also goes to h to the 6th, so h to the 6th times 2. Do the same thing with the other side or the other monomial on the right. Make sure g to the 4th gets raised to the 4th power, so times 4. And h to the 2nd gets raised to the 4th power, so h to the 2nd times 4. When we simplify this, now this one, if you guys got to this one, you're going to have to make a change, some of y'all. You might have written +25 because you looked at this as if it was -5 squared. It's not. It's 5 squared, and then you drop your negative down. This is the only thing that's being squared. 5 times 5 is 25, then your negative comes down. It's g to the 5th times 2, which becomes g to the 10th. It's h to the 6th times 2, which is h to the 12th. Then we keep on going. It's multiplying because everything's next to each other, still multiplying. G to the 4th times 4 is g to the 16th, and h to the 2 times 4 is h to the 8th. Again, we're multiplying. Now it becomes, if you look back, now it acts just like number 28. You're multiplying the same bases, all of these g's and these h's. Number -25 will stay by itself. G times g becomes g to the 10th plus 16. Notice what we did there. We went from multiplying them to now we're adding them since we're just multiplying the same bases. And h to the 12th times h to the 8th becomes h to the 12 plus 8. So -25, g to the 26th, h to the 20th. And that's all we can do with that problem. There's no negative exponents. Nothing has to move up or down. We don't know what g is. We don't know what h is. But we know that they're raised to the 26th and 20th powers, respectively. For number 31, it says x to the 5th over x to the 9th. Just like when you are multiplying the same bases, like the end of 30, you added the exponents. On number 31, it says over. Remember, that bar means divided by. Now we're dividing the same exponents, x divided by x. Addition goes with multiplication. Subtraction goes with division. So it becomes x to the 5 minus 9, which gives you x to the -4th power. And then it has to do the elevator rule. It's at the top. Everything's over 1. It has to go down. 1 over x becomes to the +4th. Number 32 says 3x over 2 to the fourth power. Everything needs to get the fourth power. So 3 needs to get the fourth power. X to the first power needs to get the fourth power. And 2 needs to get the fourth power. So 3 times itself 4 times. 3 times 3 is 9, times 3 is 27, times 3 is 81. X to the fourth power over 2 to the fourth power. 2 times 2 is 4, times 2 is 8, times 2 is 16. And this will be our simplified answer, 81x to the fourth over 16. Number 33 is a little bit easier of a problem. The square root of x, now I'm thinking the other way. The square root of 6 plus 2 times the square root of 6. Had this said x plus 2x, we would all write 3x with no problem. Most of y'all can do that with no issue. Your radicals, when they're the same, act the exact same way. This is just like 1x plus 2x. So this is just like 1 times the square root of 6 plus 2 times the square root of 6. 1 plus 2 is 3 times the square root of 6. 34, we're doing scientific notation. Notice 34 is a great big number. 35 is a very small number. In scientific notation, your number has to be between 1 and 10. Remember, that's the key. It has to be between 1 and 10. You can't change the number. All you can do is move the decimal. It starts there. You need to make that decimal fall right between the 8 and the 6 because it's going to say 8.67. That number is between 1 and 10. It's going to be multiplied times 10, and it's going to move over how many times? That's the key. It moves over 3 times right there, 6 times right there, 7, 8, 9 times. It moves over 9 times, so 8.67 times 10 to the 9th power. Great big number to check just in case you forget if it's supposed to be positive or negative. A great big number is going to be positive. 8.6 times 10 to the positive 9th. Same thing holds true with number 35. The number has to be between 1 and 10. So the only place we can put this decimal is between this 8 and this 0. If we put it after the 0, it'll say 80. That's way bigger than 1 and 10. If we put it after the 5, it'll say 805. If we put it before the 8, it'll say 0.8, which is less than 1. It's got to be between 1 and 10. So we need the number 8.05 times 10. But we have to find out how many times we move our decimal. You move it from where it is. It starts here. 1 time, 2 times. You only move it 2 times. So 8.05 times 10, you moved it twice, but it's a very small number, so it's not a positive 2. It is a negative 2. 8.05 times 10 to the negative 2 power. Number 36 says write it in standard notation. So now we're going from number 34 and 5 was going from standard to scientific. 36 is the other way. You're going backwards. So it says write the number in standard notation. Looking at this negative 2 tells you it's going to be a very small number, or you're going to move it to the left. So you have 9.07. 2 tells you to move it 2 times. We're going to move it left 1 time. That's where 1. 2 times. So we only have 1 spot that we have to fill in. So 0.0907 is your standard notation. Number 37. Number 37 says the square root of 10 over 81. Just like the last square root problem we did, separate them for sure. The square root of 10 over the square root of 81. Remember, that means what times itself is 10, so we'll leave it. There's no number that multiplies, or there's no integer that multiplies by itself and gives you 10. Then it says what times itself is 81. We know that 9 times itself is 81. Notice it comes from outside of the radical symbol. Remember, there's 3 questions you have to ask yourself, 1, 2, 3, to determine if this is simplified or not. The first one, are there any perfect squares? Any perfect squares. That means anything like 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. And it keeps going. Can you multiply any of these numbers by something and get 10? That's the first question. No is the correct answer in this case. So that's good. No. So we passed that one. The second question is, are there any radicals at the bottom of a fraction? I'm just shorthand it like that. Bottom of a fraction, any radicals in the denominator. As you look at the bottom of this fraction, no. 9's by itself. It's not under a radical symbol. The last question, are there any fractions under a radical? Like so. And some people get confused when they look at a problem like this because they see the square root of 10 and then they see over 9. But notice the square root of 10 is just at the top of the fraction. It's not the whole fraction underneath it. So this is a simplified answer because you answered no to all three of these questions when you're dealing with radicals. Number 38 says solve the equation, then check your solution. The square root of 3 plus 5 equals 11. Very simple equation. Just like addition cancels out subtraction, just like division cancels out multiplication, square roots are canceled out by squaring something. So in order to cancel out the square root of r plus 5, you square this entire thing. That will cancel this out and just leave you with r plus 5. But you can't just square the one side. You have to square both sides. So equals 11 squared. R plus 5 equals 11 squared, which is 121. In order to get r by itself, is a simple equation now. Get rid of plus 5 by subtracting it. R equals 116. Then it says check your answer and see if it's correct. The square root of, in place of r, we'll plug in 116 plus 5 equals 11. The square root of 121 equals 11. That is a true statement. So when you take the square root, it means what times itself is 121? 11.